Welcome. In this video, we take a look at Unit 2 and we begin lines. We will cover two sections, 2.1, which is very short, has only two objectives, and we will just start 2.3. So we'll do all of 2.1 and then just the first two objectives in 2.3. So in 2.1, we start with graphing. We want to put points in a plane, and we have this coordinate plane that you can see here. And I can put a point on the coordinate plane, and points have coordinates. They have an x coordinate and a y coordinate. So the x coordinate of this point is 4, and the y coordinate of this point is 2. So we write this as an ordered pair, 4, 2. I could put a point someplace else in the plane that can make the x value negative. So this point has coordinates -2, 3. Here's a point with coordinates -3, -5. And here's a point with coordinates 1, -2. So this first point that I drew lives in quadrant 1. Quadrant 1 is the set of all possible points where the x-coordinate is positive and the y-coordinate is positive. Quadrant 2 is the set of all those points in the top left where the x-coordinate is negative, y-coordinate is positive. Quadrant 3 has all the points where x is negative and y is negative. And then quadrant 4 has all the points where x is positive and y is negative. I don't know why, it's just tradition, but you always see quadrants numbered with Roman numerals. Some points don't live in one of the quadrants. So I can have a point that lies right on the x-axis. So this point has coordinates 4, 0, and it does not live in quadrant 1 or quadrant 4. It's on the dividing line between those two quadrants. Likewise, here's another example. The point 0, -3 lies on the x-axis between quadrants 3 and 4. Okay, let's talk about distance. What is the distance between 2 points? Here are 2 points, -2, 1, and the point 2, 4. And maybe I'll draw just a little segment between them. What is the length of that line, or what is the distance between those 2 points? And there's a neat trick for figuring this out. We make a triangle. In fact, we make a right triangle, and we're going to use the Pythagorean theorem. So this horizontal segment, what is the length of that? Well, that's 4. And the vertical segment, what is the length of that? That's 3. The hypotenuse, let's call that d. And so by the Pythagorean theorem, d squared equals 4 squared plus 3 squared. I could solve for d by taking the square root of both sides. 4 squared plus 3 squared. So that's the square root of 16 plus 9, which is the square root of 25, which is just exactly 5. So this distance between those 2 points is 5. Here's another example. Let's do the same thing, but I'm going to figure out my lengths of the sides just a little bit differently. Now, visually, the length of the bottom side is pretty easy. We can see it's 2. But what am I doing with those coordinates to actually figure out 2? That's the difference in my x-coordinates. I have the 1 and the 3. So that 2 is really calculated as a 3 minus 1. And what about the vertical side here? How am I really figuring out that length? Of course, we can see that the length is 3, but how am I using the -1 and the 4 to get that? I can take my -1 and subtract a -4. -1 minus -4 equals 3, and that's what gives me that length. I take the larger value and I subtract the smaller one, so I end up with a positive number that gives me length. But once again, if my hypotenuse is d, now I have d squared equals, let's see, that change in x, so 3 minus 1 squared, and then the change in y, -1 minus -4 squared. So let me simplify that. So that looks like 2 squared plus 3 squared. So I can take the square root of both sides. 2 squared plus 3 squared. Do some simplifying. Let's see, 2 squared is 4, 3 squared is 9. and I end up with the square root of 13. And that can't be simplified anymore, so that's just the answer. The answer is the distance between those 2 points is the square root of 13. All right, how does this work in general? In general, let's say I have 2 points, P1, which has coordinates x1, y1, and point P2, which has coordinates x2, y2. So to find the distance, it's the square root of the difference in my x values squared plus the difference in my y values squared. So that's what I did in the previous example in order to figure out the distance between the 2 points. So why don't you give this a try? What is the distance between the points 1, 6 and 3, 10? So use the distance formula to figure that out. Pause the video, give it a try, and then restart the video when you're ready to check your answer. Go to it. All right, we're back. Hopefully you gave this a good try. So I might let 1, 6 be the points x1, y1, and let's label the other point x2, y2. It doesn't really matter which way you do it as long as you're consistent. Distance formula says the distance between the 2 points looks like this. So I can plug in the values. We end up with the square root of 2 squared plus 4 squared. So that's 4 plus 16, the square root of 20. So square root of 20 is the exact answer. That is the distance between these 2 points. If you plug that into your calculator, you can get an approximation, 4.47. And when you see the squiggly equals sign like that, that means approximately. So the square root of 20 is approximately 4.47. Let's take a look at midpoint. I have the point 1, 2 and the point 5, 4. What is the midpoint of those two things? Well, visually we can figure this one out pretty easily. It looks like the midpoint ought to be right there. How I figure that out is I look at the difference in my x's. So just in the x values, how the x has changed. And I want to take the middle of how the x has changed going from one point to the other. And similarly, I can look at how the y values have changed. So going from one point to the other point, there's a change in the y values. And so I can take the middle of those y values. And where the middle of the x's meets the middle of the y's, that's where the midpoint is. Here's the formula in general. Let's suppose I have a point x1, y1 and the point x2, y2. Then the midpoint between those is that formula right there. And look how on the left coordinate, that's really the average of the two x values. And on the right, that is the average of the two y values. All right, you give this a try. Use that formula and find the midpoint of the 2 points that are shown up on the screen. So give it a try and unpause when you're ready to continue. All right, so it turns out that the midpoint of these two is -1/2, -7/2, and it looks like it appears right there. Moving on, now we take a look at lines. And we'll look at the most important feature of lines, or perhaps the most important, which is slope. Every line has a slope. How can I figure out the slope of a line? So here is a random line I drew, and one of the first things I like to do is look for what we call lattice points. Let me write this out, L-A-T-T-I-C-E, lattice points. And these are points on the line that have integer coordinates. Like I see one right here. That's the point 2, 3. And I move up, I look for another lattice point. Oh, here's one. That looks like it has coordinates 4, 6. Going back down, oh, the origin. There's a lattice point, and way down there at -2, -3. Once I find some lattice points, I want to find the change in x and the change in y. So to get from this lattice point up to the next one, how does my x value change? My x value increases by 2. And how does the y change? The y value increases by 3. Now when I write change in y, a lot of times mathematicians abbreviate that with a capital delta y. That means change in y. So the change in y is 3. And the change in x was 2. And the slope is figured out by taking a fraction that has change in y divided by change in x. So this particular line has slope 3/2. Now, it doesn't actually matter which 2 points on the line you take. You can take any 2 points. For example, let's take the very bottom point and the one on the very top. And I'll draw a big change in y and big change in x. So how about the change in x starts from here and it goes that much over, and the change in y between those 2 points moves up like this. My change in y, how far up did I move? It looks like I went up actually 9 units. So change in y was 9. How much was my change in x? I went across, looks like 6 units. So change in y divided by change in x, 9 over 6. And when I simplify that, 9/6 reduced becomes 3/2 again. So anyway, any 2 points that I use, if I figure out the change in the y coordinates divided by the change in the x coordinates, that's what gives me the slope of the line. Here's another example. This one slopes down. We'll find some lattice points here. So this one has a few more lattice points than the previous example. There we go. I'll take a couple lattice points and I'll see how the x value changes and how the y value changes. So the x's, as I move from left to right, it looks like the x coordinate between those 2 points has increased by 2. However, the y value between those 2 points, this point on the left has a y value of 5, the one on the right has a y value of 4, that has decreased by 1. So my change in y divided by change in x, my change in y was -1, change in x was 2, so -1 over 2, that's a -1/2. So this line has slope -1/2. All right, how about a perfectly horizontal line? What is the slope of this line? Let me just pick 2 points on this line. And how has the change in, I always start by figuring out change in x. For some reason, I find that easier. How has the x changed? Well, I've gone from 1 to 5, so that's a change of x by 4. But how has the y value changed? The y value hasn't changed at all. Initially it was 2, and at the end it was still 2. 0 over 4, and 0 divided by 4 equals 0. So the slope is just 0. Whenever you have a horizontal line, the slope is 0. All right. Horizontal lines have a slope of 0. One last example. How about a perfectly vertical line? Again, I'll just pick a couple random points on there. It doesn't really matter. I want to figure out change in y divided by change in x. How about the x? Oh, the x coordinate doesn't change at all. That's a 0 there. My y has increased by 4. But something is terribly wrong in this situation. 4 divided by 0 does not exist. That is undefined. We cannot divide by 0. So in fact, we say that the slope of this line is undefined. The slope of a vertical line is undefined. So horizontal line has a slope 0, vertical line undefined. In general, let's say I have a line and there are 2 points on this line, x1, y1, and another point, x2, y2. If these are 2 distinct points on a line, then the slope of the line is m equals y2 minus y1 divided by x2 minus x1. Very often, the slope of a line is indicated with the variable m. For example, let's try this one. Let's find the slope of the line containing the points -1, 2, and 5, 9. So I can call this x1, y1, and x2, y2. So I'll figure this out as y2 minus y1 over x2 minus x1. Be sure that your subscripts match. If you do y2 minus y1 on the top, you have to do x2 minus x1 on the bottom. So 2, 1, 2, 1. So my y looks like 9 minus 2, change in x looks like 5 minus negative 1. So that's 7 over 6, and that's the end. That doesn't reduce anymore, so the slope of the line connecting those 2 points is 7/6. Here's one for you to try. Pause the video, give this a try, and then restart the video again when you want to check your answer. So it looks to me like the change in y is 10 minus negative 4, and the change in x is negative 7 minus 3. So that's 14 over negative 10. So I can pull the negative out, and I can reduce 14 over 10 to make that 7/5. So negative 7/5 is the slope of that line. If we have a point and a slope, then we can graph the line. In fact, if you think about it, that's really all you need. If you know a point, well, there's lots of lines that can go through a given point. But once you have a point and you have a specific slope, there's only one line that can go through that point with that slope. So that's what we often do. We often have that information, a point and a slope, and we got to figure out what the line looks like. So in this case, I have a line that goes through the point 2, 3, and I want to see that it has a slope 1/3. So let's draw the point 2, 3. So there it is on the plane, 2, 3. And now what I think is that for that slope 1/3, that's my change in y over change in x. So my x can increase by 3 and the y will increase by 1. So I'll increase by 3, my x increase by 3, and my y goes up by 1, and I've got another point. I can move my x forward by 3 and my y up by 1, and I have another point. You know, I could also call this a negative 1 over negative 3. Maybe my x will go back by 3 and my y will go down 1. So let's try. X can go back by 3 and the y can go down 1. So back by 3 and then down 1. So here we go. We have a line that goes through our initially given point and has a slope 1/3. Here's another example. Let's graph the line containing negative 2, 7 that has a slope negative 3/4. So I will plot the point negative 2, 7. There it is. And this negative 3/4, maybe I'll put the negative up on top. And we'll call that negative 3 over 4. And I'll think of that as my change in y over change in x. So my x will increase by 4 and my y will decrease by 3. So my x increases by 4 and my y decreases by 3. My x increases by 4 and my y decreases by 3. So I think on this graph I only have enough space to draw these few points, but that's enough to draw a line. So very roughly, just got a little hand sketch here, it looks like my line is something like that. There's an example of a line that goes through the point negative 2, 7 with the slope negative 3/4. Sometimes we want to know a few other points on a line. I know a point and I know a slope. Can I find a few others? So here's the example. Suppose a line has slope 3 and it goes through the point 10, 19. Let's find a few other points on this line. So here's my point 10, 19. Well, slope 3, how is 3 like my change in y divided by change in x? And here's where it's nice to remember that 3 can also be thought of as a fraction, 3 over 1. So this is telling me that as my x increases by 1, the y will increase by 3. So even without a graph, just looking at these numbers, I can make my x increase by 1, so it goes from 10 up to 11, and the corresponding y will increase by 3, so 19 up to 22. So there's another point on that line. I can make my x increase by 1 up to 12, and my y will increase by 3 up to 25. X increases by 1, y increases by 3, 28, and so on. Now, I could also think of this slope of 3 as a negative 3 over negative 1. And so if my x decreases by 1, my y will decrease by 3. So how about going up now? 10, I'll decrease that by 1 to make 9, and my y will decrease by 3 to make 16. And 9 can decrease by 1 to make 8, and 16 can decrease by 3 to make 13, and so there we have it. So given my initial point, I was able to use that slope to figure out a few other points on that line. Alright, so we really hit the basics today with some graphing on the plane and looking at some key features of lines. We looked at distance, midpoint, just kind of have to do with points. But then getting into lines, we see that the most important thing is a slope, and really understanding slope as a change in y divided by the change in x. Alright, that's it. Let me know if you have any questions.